Most of us watch science fiction movies in which it is shown that people live in space, human beings have colonized Mars and Moon, and life exists there. Everything is happening the way exactly it happens on Earth. So is it still fantasy or it is quite probable now?
Yeah, it will be a reality in this century, but in this decade, visiting space is going to be a reality well within a decade for sure.
Yeah, both of us have very young kids, so we are working very hard for making space travel happen in the future for sure.
Good evening, ladies and gentlemen, members of the audience. This is the last session, but I really look forward to this session. In fact, when we were deciding who will be the moderators, who will be the people who will be coordinating all these sessions, I volunteered for this session. Despite the fact that I have so many other organizational responsibilities, I really wanted to have a conversation with the two of them. Firstly, it's very rare for the two of them to share a stage. Not that they are competitors, they operate in different space, literally, but for various reasons, due to scheduling and other problems, it's very difficult to get both of them together. So it's one of those rare occasions. And the other reason why I really wanted to be a part of this is because I really feel very proud about them, the kind of achievements they have. See, their titles may not tell you much. CEO Dhruva Space, co-founder Skyroot. But if you do a little bit of search, what has Dhruva achieved, what has Skyroot achieved, your mind will really boggle. They are the first in the country when this sector was opened for the private sector to launch rockets in the space, to launch micro-satellites, nano-satellites, as it is called, in the space. Both are from Hyderabad. Both have started their journey here, both Dhruva and Skyroot. And of course, their reputation today has spread far and wide. They have received, this began as startups, modest startups, but they persevered. They got some support, some push from the Telangana government as well. But today their reputation is spread far and wide. They are very, very sought after. They are the poster boys of the new generation startup world. As you would know, 10 years ago, 15 years ago, startup world started by, of course, not that I'm kind of undermining anyone, but usually copycat kind of products. If someone has done something great in the US, let me try it in India. And because ours is a huge population, if I get the model right, I'm bound to make money, I'm bound to be kind of one of the wealthiest and all. So that was the model. But thereafter, as you know, many of our startups have developed original products, original solutions, and they are the two exemplars of what really talent and creativity and imagination, as we say, sky is the limit. So this is a phrase which they really live on a day-to-day basis. Sky is really the limit. So today's conversation, I would, we have not frankly prepared for anything. I don't have any set question. It's not that I have to look into my phone to decide what to ask or anything. So I thought I'll keep it very conversational and straight away ask you that this is a very unusual kind of a space to get into. I mean, both of you are engineers. Most of the engineers either would like to work for one of the manufacturing companies. In the previous panel, we are some of the top manufacturing companies of our country here. Or they would like to become an entrepreneur, but they would like to do something with internet, with B2C or B2B at the most. How did this idea come that you can do something which relates to the sky, to the space? Because there aren't too many role models in our country. As I mentioned, both of you are pioneers in this. So what really spurred this idea that let me get into flying satellites or rather launching satellites, launching rockets in the sky? How did this idea come? So Sanjay, will start with you and Bharat thereafter.
Yeah, thank you, sir, for having me here. So I actually started building satellites when I was in college. After the success of Chandrayaan-1, there was a scientist from ISRO who had come to our university in Chennai. I graduated from SRM University. And he mentioned that we as students could actually build a satellite. And I was in an auditorium as big as this, and I wasn't really convinced that this is something that we as students could actually do. I also had an unusual hobby. I'm a ham radio operator. And, a couple of months down the line, our university decided to actually support that initiative. So initially, ISRO had given us this challenge that within a 2-year period, we have to build a full satellite to their standards and deliver it to them. Our first approach was that we would just buy components from all over the world and put it all together, because that was probably the fastest way to do it. But when we started doing that process, we realized that the cost of doing that was very, very high. It was running into tens of crores. So as the saying goes that necessity is the mother of invention, we actually ended up building the whole satellite ourselves. And in this process, I just started asking our mentors that when we as students are building satellites, when as India as a country we have gone to the moon, why is it that there's no single private company that exists in the country? So nobody actually gave a convincing answer to say that, you can't start. And that was actually the prime motivation for us to start thinking about building a space technology company in India.
But Bharat, before you answer, I just want to add one more question. And Bharat, then you answer both the questions together. So despite the fact that ISRO, there was an interface and there were mentors, and you were studying in a college which encouraged all this, did you never get a sense that it is still risky and it may work, it may not work, and if it doesn't work, am I doomed, or is there something else that I can move very quickly into? Or were you determined that even if it doesn't work, this is what my passion is and I stay committed, I run the course? What was going on in your mind? Did you ever think about risks?
Certainly, sir. I think, when, as a college student, when I was planning to start off, I obviously needed a team. And the first people that I reached out were my team members in the satellite project. And even they were not confident that, something like this is actually going to work. I would say, my university professors and my parents were my strongest pillar of support, who actually encouraged me to try before taking a different route. So the first thing that we did was, we just took some of the parts that are used in the satellite and tried to sell it in the overseas market through eBay. And we actually found success in that model. And when I went back to my colleagues and said, hey, it's possible, so I think we should give it a shot. There was still a lot of pessimism that, it is a very difficult place to find customers, so on and so forth. So the initial days were certainly very tough, but over a period of time, things evolved, I would say.
Bharat?
So for us, both me and upon my co-founder, the journey started in a similar way. So straight out of the college, after graduating from IT, I'm from IT Madras and from IT Kharagpur. We were lucky enough that when we were passing out, ISRO was coming for campus placements to IT. So, and being space enthusiasts, this one of the, and ISRO was one of the well-respected government research organizations then, and being space enthusiasts ourselves, that was an opportunity we wanted to clinch on. And luckily, we got assigned to the rocket center of ISRO, called the Vikram Sarabhai Space Center, which builds the rocket. And we also, luckily, we joined in a time in 2012 timeline where the India's biggest rocket, the LVM-3, the one which launched the Chandrayaan-3, it was under the final phases of development. The last 20% of the development was undergoing, and we got to work hands-on on that rocket, finalizing various systems, and got to see that rocket going to its first launch hands-on. That was a huge learning experience for us because rocket in general is a system of systems, and it involves multifaceted engineering efforts. Like compared to our peers, like being in electrical engineering, if I join any semiconductor company, I'll only be like, of course, we'll be doing a cutting edge work in the domain, but we'll be restricted to that specific domain. The exposure to other fields of engineering will be very minimal in a corporate MNC opportunities we can explore. And that was like a huge learning experience for us, especially the kind of engineering fields that go into building a rocket, the rigorous review process, the tech review process, and all that was a great learning experience. And parallelly, we were observing what's happening around the world, especially the private industry taking shape, not only in rocket industry, in developing satellites in US and European ecosystem. And India, space sector is one domain where India can rub shoulder with the top 5 nations in the world. And thanks to Vikram Sarabhai, who started this space program in 1960s. We felt that like having such strong government research ecosystem and having such strong vendor ecosystem developed over decades, we felt India, it's an eventuality that private industry coming up in India is an eventuality. Already there's a private industry, but only limited to manufacturing and supply of components. So what we need to bring essentially, what we need to privatize essentially is this design and quality expertise, which was only with ISRO, that needs to be privatized. So, and we wanted to solve that with starting a rocket company, because that was a field of expertise, and we were seeing a private rocket companies launching just into 2017, just 1 year before our launch. And that gave us huge inspiration that if they can do, and India is a country that it's an eventuality, it should happen. With that conviction, we started in 2018. But as you asked, it was risky because there was no standard policy in India back then, like to...
And also, see, even though ISRO is a government institution, but it's a very specialized niche institution. So to quit an ISRO job and try something, I would consider it to be a very risky it's a very gamble kind of a decision.
Yeah, indeed. That was kind of a, it took us 1 year to convince ourselves, for both me and Pawan, to take that call. But after the strong conviction that that's needed to happen, of course, there is additional risks. Basically, when we start a private venture, at that time, the startup venture ecosystem was more adept to like analyzing SaaS or e-commerce based startups. No, even the venture capital, the partners in the venture capital ecosystem do not have the wherewithal to invest and analyze a deep tech system, especially a space tech ecosystem company. So, and in addition to that, like most of the deep tech ecosystem have this problem of tech risk and market risk. In addition to that, in space technology, there's a regulatory risk because there is no clue for venture capitalists that whether this will ever be allowed, what they're trying to endeavor. So with all these 3 risks, it was certainly a difficult time to raise capital. But we were lucky enough to, in the initial phases, we were lucky enough to find some entrepreneurs who have themselves, like first-hand entrepreneurs who have themselves have this strong vision for space to invest the initial seed capital with which we got started. And
wonderful. So again, lots of commonalities in your stories. Both were inspired by ISRO. You were placed in ISRO. So, but you realize that there are opportunities which you can do yourselves instead of waiting for someone else to do, and you took that chance. While the element of risk played in your mind, but your determination was stronger and you have come here. So very admirable. I will jump fast forward now. I mean, this was the way you started. But what all have you achieved so far? I mean, you mentioned that you started in 2018, so 6 years have gone by. About 5 years for you also, is it?
So we started in 2012.
Okay, so about 10 years, 12 years for you. So for a 12-year-old company and for a 6-year-old company, what are your achievements? If you have to write your biography today, autobiography today rather, what exactly will you highlight as the stellar moment which you feel the most satisfied about?
So I think we are one of the only companies in the world that is able to stitch the 3 pillars of space technology together, which is the space, launch, and ground segment. So typically, for decades, the space industry, the launch companies were only focused on building launch vehicles. Satellite companies were just building satellites. And ground segment companies were just building the Earth stations. But in this decade, we are seeing the need for launching tens, hundreds, and thousands of satellites. So it took us, I would say, almost a decade to stitch these three pillars together, and I'm really proud that majority of the components of these pillars are designed, developed, and manufactured in India. So that is something that I'm super proud of.
No, no, excellent. That's excellent. Bharat, what about you?
So we started in 2018, and in the initial phases, we became we were able to, especially in the propulsion technology, we testified first a storable engine, first private sector storable engine technology, and we even testified first a cryogenic engine that is ever built in private sector in a fully 3D printed cryogenic engine with methane and LOX. And the most significant achievement of us is we became in November 18, 2022, we became the first private company, not only in India, in entire South Asia, to launch a rocket to space. And that is an incredible achievement. With that, like in a private company domain, even none of the European companies have this metric, and we became the fourth nation where a private company has achieved that milestone. And yeah, that was one of the tremendous achievements for the company, but also for Indian space sector, because the space reforms were just just started. And there's a regulatory body called InSpace, which was formed.
InSpace.
Yeah.
So that is wonderful. In fact, we should feel very, very proud of these achievements. And despite these kind of achievements, they're very humble, they're very approachable, and they still feel that they have that startup kind of zeal and mentality. They don't see themselves as bosses with some hundreds of employees and all that. So let me now change track a little bit. Both of you, since you launch rockets, you launch satellites, you have a bigger understanding of space, unlike many of us who, of course, we have a layman kind of understanding about space, but still the kind of understanding you have is definitely far more. So what do you think about the ways in which governments or the private enterprises, etc., have utilized what all is the benefits that are possible for humanity, for mankind, how much of it has been channelized? While the two of you work here in India, we know what Elon Musk is trying through SpaceX and through Starlink and all that. So how much of the potential that space offers to improve different aspects of our living, of humanity's improvement of their quality of life, how much of it has been kind of utilized? What are the other big challenges which are still, let us say, dark or gray? We have still not really fathomed how to go about it. So what do you think is the current landscape, and what else do you think the people like you should endeavor at?
So, as most of you might be aware, like one of the common applications of space, which we all currently use, which we can't live without day in and day out, or the GPS, the direct home television we all enjoy. These are all common use cases most of the public are aware. And in addition to that, like there are a lot of applications with respect to Earth observation, like where like observing Earth from space, both with respect to defense, surveillance aspect, and also for weather monitoring. ISRO data helps the fishing community a lot. Every year, billions worth of money is saved by, because of the good guidance that fishing community receives in catching, going to the right places to catch fish, and which is the guidance that Indian government publishes with the help of ISRO data. And as more and more adoption applies, the banking and insurance sector heavily uses that, and even in India, that applications are increasing with respect to using geospatial data for insurance claims, or like all sorts of insurance applications, whether it can be assessing the damage a flood or a disaster can make, or predicting how much prone, disaster-prone a land is before giving an insurance. So the banking and insurance sector uses a lot of data, and that is increasing. And agriculture sector also is going to use a lot of data. And other application is communications, like that's the major applications. And what we're going to see a transformative change in this decade is broadband from space, from satellites that are being launched from SpaceX, OneWeb kind of companies, where we'll be achieving like whole Earth is going to achieve get high-speed broadband. We're going to get high-speed broadband in flights, in very remote areas. Working remotely is going to get even more easier with a very good broadband. All this is going to get into reality in this decade, before this decade ends. So that is kind of the transformative experience we're going to do with respect to space communications. There's a lot of future. I'll let Sanjay also comment.
So a couple of more examples that I can talk about are the following. Space is in everybody's life. It's just that it goes unnoticed. If any of you have actually taken a LASIK surgery, you know, the technology behind that was actually built for human space flight in the 70s. If you have heard this company called Goodyear, which makes tires, they were initially making strands for parachutes used in the human space flight. So a lot of technologies that were invented for space have now found applications on Earth. And I believe that investing in space technology will lead to betterment of life on Earth in several ways. Some new areas which are upcoming are also in drug discovery and drug development. Typically, where it takes about 7 to 10 years to develop a new drug, people are trying to leverage developing these drugs in the microgravity environment in space and then, you know, shortening that time span. Obviously, I think one of the things that I'm extremely proud of talking about as Dhruva Space is today, India as a country has roughly about 55 operational assets. But, you know, satellites, yes. You know, last couple of weeks, you know, it's been raining and there's been a lot of floods everywhere that has happened. So we built this tool called AstraView, where we are aggregating data from almost about 260 satellites. And today, you know, if you take the map of India, you draw a polygon, it will tell you what historical data is available. And you can also task a satellite as early as few hours from now, and then compare what are the changes that have happened. And this is just a small example of how space and satellites are going to transform the lives of people in the coming few years.
Wonderful. So finally, because this is the Global AI Summit, I have to ask a little bit about AI as well. So any applications which you are driving using AI, which you can share a little bit about? And how are you sourcing that technology? Do you have an in-house AI team, or do you work with some research institutions or vendors, or how does it happen? Or so far, you are not fully into AI. What is the AI understanding?
Yeah, so as Elon Musk also recently quoted, like SpaceX uses the least AI in general because even the reusable launch vehicle technology and the Starlink there, it uses the application of AI is very minimal in execution of the problem. Solving the problem of reusable, because it's all solvable with already developed algorithmic approach of solutions are already developed and solved both with respect to communication and this thing. But AI, the major impact AI can do with respect to not only space tech, any deep tech engineering process improvement is, of course, what we the recent buzz is all about generative AI using the technology called transformers, where large language models, which essentially just predict the next most sensible word. And with the good training data, it can make sense in any subject. But the key thing, use case for engineering process is there is something called physics-informed neural networks, which are being trained. So where you almost know people in engineering field, there's a lot of time spent on doing structural analysis and CFD analysis for the fluid flow, where the numerical computation is involved, which takes a lot of time, lot of high performance compute in engineering process. That data, like historical data of the results, if it's trained, these physics-informed neural networks will use it as a constraint. The rules of physics are used as a constraint for the outcome. And that way, what we can get if a CFD simulation that takes hours and gives a result, with the trained model can actually present it in seconds. Basically, the computational engineering process time is going to get like revamped significantly, and we are seeing examples of that being applied even in space technology. And but currently those technologies are very proprietary, and open source solutions, once they come, we are trying to explore those kind of open source solutions for the physics informed neural networks in general.
What about Dhruva?
So in our line of business, so I would just say there is a hardware piece and there's the software piece. So I gave the example of how we are able to harness the data from about, more than about 260 satellites. What we are trying to do as a company is we are trying to work with also the ecosystem, which is, well ingrained into some of these technologies. So for example, a company like a Cropin or, ITC could actually leverage some of these data sets and use other data sets and apply AI on top of that. In the upstream side of things, where we are doing largely the manufacturing or innovation at the spacecraft level, we haven't come to a final conclusion, but some of the ideas that we've been brainstorming on is, over the last 30, 40 years, there's also a lot of developments that have happened on Earth in automotive industry, in oil and gas industry, in the nuclear engineering domain, so on and so forth. So there's tremendous amount of literature that is available in terms of what people have developed in these sectors. So we are trying to see if some of the technologies that have been developed in these sectors can also have a hardware-related solution for some of the problems on building spacecrafts itself. So those are some of the areas, but otherwise regular applications of ChatGPT, so on and so forth, continues.
Wonderful. So unfortunately, while there are so many AI companies here, you won't be their clients in the near future, is the message that you are giving. So one final question. Most of us watch science fiction movies in which it is shown that people live in space, human beings have colonized Mars and Moon, and life exists there, everything is happening the way exactly it happens on Earth. So is it still fantasy, or it is quite probable now? I mean, are we getting closer? In fact, the first speaker this morning told us that by 2035, we would have cracked the solution to living beyond 100 years of age. And he was very serious about it. He brought lots of data and lots of studies to prove that. So how close are we to, so tomorrow if I have to, so I'll be completing my tenure in the government in a few years. Can I say that thereafter I will shift to Moon or I will shift to Mars? Is it a reality or is it fantasy?
Yeah, it will be a reality in this century, but in this decade, visiting space is going to be a reality well within a decade. For space tourism is going to happen very quickly in the late decade and early. Like it won't be like too much affordable like going on a flight, but within a decade it will be at least a pleasure trip for at least the affluent can afford to have space tourism, and it's only going to get economical as. Basically, the cost of space access is going to determine a lot of these applications, how quickly the space tourism, things like, as Sanjay mentioned, the pharma industry is doing a lot of industry. But the manufacturing, for it to go to scale, to get to huge machinery to go to space, to take advantage of these microgravity environments, the cost of space access, once it reduces by an order of magnitude due to reusable technologies or whatever, all these applications, like which otherwise won't commercially make sense, suddenly will make sense, and especially things like space tourism, manufacturing in space, and hotels in space if you want to go a longer term as you wish to, all will become a reality, but in this century, it is not going to be far enough. And like our kids who are born in this decade are going to experience all of this in their lifetime, for sure.
Yeah, both of us have very young kids, so we are working very hard for making space travel happen in the future for sure. So I agree with Bharat that permanent settlements might be taking a lot more time. But in terms of making space accessible to a lot more people and going to, doing a trip around the Earth, I think it is definitely going to be possible in the next 15, 20 years.
Thank you. It was wonderful talking to both of you, Sanjay and Bharat.
To stay informed about the startup ecosystem, subscribe to My Startup TV.